Okay, today we are going to be talking about the LeetCode704 question 704 binary search. Let's see this problem. So, given an array of integer names, which is sorted? Notice here is sorted, okay? And then an array target, okay? Write a function to search a target in names. If the target existed, then return is a index, not the element, is index. Otherwise, return -1. Okay, so you must write an algorithm with a big O log n. This is runtime. And check here the integer in names are unique. Okay, so also pay attention about this part. This is or is very important. Okay, so for this problem, because we need to write a algorithm with the O log n, so we can see this problem we can use. We can use actually. Oh, sorry about that. So we can use binary search technical. Okay, the steps. Okay, so binary search. So what's binary search? So binary search actually is an algorithm binary search is an algorithm that divides the search space in half after every single comparison. Okay, and then the binary search should be considered every time we need to searching for an index or an element in a collection. In this case, we are searching index, so we use the binary search. Also, we need to pay attention about this. If the collection, I mean, if the names is not ordered, that means unordered, then we can always sort it first before applying the binary search. Okay. Let me give some more information about the binary search. The more knowledge. Let's do this way. 1 second. Let's do this. Okay, let's do this. So what's binary search? Binary search here, this is the definition. The binary search is an algorithm that divides the search space in two after every comparison. Binary search should be considered every time we need to search for an index. Our problem here is searching for an index. Okay, so if the collection is unsorted, we should sort it. Okay, this is the definition. Okay, there's a 3 steps for the binary search or 3 main sections. So the first one we will do pre-processing. That means if the collection is unsorted, we need to sort it first before we do binary search. That's very important. Okay, the second section we will do the applying the binary search. We are using a loop or recursion to divide the searching space in half after every single comparison. Okay, and then after that we need to check if there's a candidate left. We need to actually do post processing. That means we need to determine the variable candidate in the remaining space. There's a 3 template very popular, can easily found at some universities website. Okay, they do have using in different scenario. Let's talking about the first one. Template 1. So first we do pre-processing. So let's check about this. When we iterate the numbers, the list or collection, whatever. So we start from left equals to 0. The right is the last element of the list or array. So and check the condition. The while loop basic condition is left smaller or equals right. That means when the left equals right, we still go inside the loop. And then, but the stop condition about this while loop is gonna be because when it's left and right is equal, we still will run. So this is a stop condition. That means right plus 1 equals to left. So what's that situation like? I can write it here. So it's much easier for you guys to understand. Okay, so in this case, we can actually, so this is left. When this is left, this is right. So that means the if left smaller equals to right, like for example, if left, so if left is here, right is here, we still run this loop and we still run again the loop. That means we still go inside the loop. That's not the stop condition. So the stop condition for left smaller or equals to right, it should be like this. That means every single element in this array, or at least we iterate everything. So there's a 0. Okay, 1 second. Let me. That means we have a 0 candidate. We have a normal candidate. We iterate all the candidate. Okay, let's check the template 2. Yeah. And also, when we use the template 1, the search condition we are talking about here can be determined without comparing to the element's neighbors. That means we are searching for, we are looking for, we are trying to find the specific element, or the index. So there's no neighbors. We don't have to do anything like checking the neighbors, the left neighbor, right neighbor, there are other things. So that's why actually in this question, we're going to use template 1. And also there's another template, like the template 2. Let's see the difference. So the 3 different template, remember, we'll use in 3 different scenario. Okay, let's talk about the template 2. The template to the right equals to length. That means we're going to check iterate from, we will start from left 0 and the last element and more than last element, so because we need to check the right element's neighbors. In that case, we're gonna use this one. So the basic station, basic station for the while loop is left smaller than right. That means that we have to make sure left is smaller than right. That means when the left equals to right, we will stop. That means we have one more element we need to do post-processing, because when the left and right equals in that situation, we are not running actually the while loop. That's why there's one more candidate left and we need to do post-processing. Let's use the template 3. So the template 3, we can notice the right equals to length minus 1. That means that we iterate, start from 0 to the last element. In this case, the left plus 1 equals to right. So that means this is the stop situation. That means that when the while loop stop, the left is here, the right is here. They are neighbors. Okay, so there's 2 more candidate. We haven't actually compared. We are not doing comparison. So that's why when we do the post-processing, we need to consider, we need to check about it. Okay, and also we can notice here the left equals to middle and the right equals middle. That means that because this is a stop condition, so we can just use this one. Okay, so the template first, we just use the minus 1 and this one, because that we actually it's also related about the iteration things, like because we iterate every single element. We don't have any candidate left, so we don't have to think about consider about the kind of the neighbors or stuff. So that's why we are trying to saving time. So we make the media plus 1 and media minus 1. And here because we just compare one neighbor, neighbors, just the right here, so just here, so the left equals to middle plus 1, and then right. And this one we need to compare, so this search condition we need to access elements immediate left and right neighbors. That's why when we trying to update, move the middle to the left and right, we kind of have this. Okay, we have two candidates. We have to the post processing, right? Yeah, this is kind of. This is the knowledge of this kind of binary search. Discuss way more about that. Yeah, let's start coding. Let's start coding. We start coding. So first, we need to actually check. Names equals to nan. This is a corner case. Okay, names the length or equals to 0, and then in this case we're gonna return -1. That means we don't have any target. Okay, and then we start to do the while loop. Let's actually initiate the left and the right equals to, because we are looking for the specific index. And we don't have to compare the neighbors or stuff, so we just use the template 1. Remember the template 1 we are just talking about. And then here we just do this -1, and then we do the while loop. We do the while loop left smaller equals to right, and we iterate every single element in this one. So let's do this. Middle equals to left plus right minus left, divide by 2. So we do this just because we are avoiding the overflow. Okay, because we check here, and then we are not doing like a left plus right, just divided by 2. That way probably overflow, but yeah, here, yeah. And then we check if names middle equals to target. Okay, if this one equals target, then what are we gonna do? That means if this one, then we return middle. That means we return the middle. That means we already found the element. This is the index. Okay, and then else if here, else if else if like 1 second, let me check. Okay, sorry, now this one. Yeah, so in this case, where we do the okay, so else if we also need to check else if the condition of this loop, else okay, else if numbers middle, if this one smaller than the target, that means our target actually is the right portion of the array or the collection. Okay, if this one's smaller than that, that means what we're gonna do, we're gonna left equals to middle plus 1. Else if it's not smaller, that means like we need to update the right equals to middle minus 1. Okay, yeah. Let's run. Or if we couldn't find anything in this while loop, okay, what are we gonna do? We're gonna return -1. Okay, let's run the test case. Let's see what's gonna happen. Okay, yeah, there's a okay, yeah. The problem is here because we are trying to actually mhm, we are trying to actually comment. Okay, accept. Let's submit. Okay, so it's faster than 100% for the Java Online. Okay, so let's talk about the time complexity. Time complexity of this problem actually is bigger O log n. So yeah, it's bigger O log n because that space complexity is big on. Yeah, because we didn't actually use extra, so it's a constant. We didn't use and stack or heap or stack or whatever. And then, yeah. Okay, this is a problem for the LeetCode binary search. Thank you for watching. I'll see you next time.